Okay, so today's notes are on arithmetic sequences. It's chapter 9, section 2. Our content objective is to define, identify, and apply arithmetic sequences, and our language objective is to use the correct terminology to describe and explain them. All right, so let's start in by actually defining what an arithmetic sequence is. So an arithmetic sequence is a sequence, which we began learning about yesterday, where the difference between consecutive terms which consecutive means back to back. So consecutive terms is constant, meaning there is a common difference. So an arithmetic sequence is a sequence where there is a constant difference between consecutive terms or a common difference between consecutive terms. So what is a common difference? This is going to be a key term for not just this section, but this unit. So a common difference is the constant difference between consecutive terms, specifically in an arithmetic sequence. And we're going to use the variable lowercase d to represent that common difference as we move forward. So an arithmetic sequence is a difference where there's an arithmetic sequence is a sequence where the difference between consecutive terms is constant. So I want to do a quick check and make sure you guys can identify what kinds of sequences are arithmetic. So I want you to identify if the following sequences are arithmetic. First one we have is going to be 3, 6, 9, 12, 15. And the second one is going to be 1, 4, 9, 16, 25. So try those out, see if you can identify it. I'm going to go over it now. So the first thing, 6 minus 3 is 3. 9 minus 6 is 3. 12 minus 9 is 3. 15 minus 12 is 3. So there is a common difference here. They differ by the same amount each time. So my answer is yes. My common difference is equal to 3. I didn't ask you to do that, but just if you want to note for yourself. For this one, the first difference is 3. So 4 minus 1 is 3. 9 minus 4, however, is 5. So already I know it's not arithmetic. Just to make sure I didn't make a calculation error, if I subtract these, 16 minus 9 is 7. And then 25 minus, sorry, that's 9. Subtraction. 25 minus 16 is 9. Did that before too. So here my answer is no. There is no common difference. So this one is arithmetic. Each term differs by the same amount from the previous, and this one is not because that is not the case. So before I move forward, let's talk about our formulas for these. So yesterday we practiced a lot with recursive formulas. So our recursive formula for an arithmetic sequence would just be a term is equal to the previous term, a sub n minus 1, plus d, so plus the common difference, so you just add the same common difference to the previous term, and that will give you the term you're looking for. And this is true when n is greater than 1, so obviously you can't plug in 1 because you can't have a sub 0. But more importantly, what we want to focus on is our explicit formula, because we will be able to find any term we want using this explicit formula without having to build an entire list. So our explicit formula here is going to be a sub n. When I say sub n, I'm meaning subscript. So a sub n equals a, your book doesn't do this, but I put 1, so I know it's the first term. We'll talk about that more in a second. So a sub 1 plus n minus 1 times d for when n is greater than or equal to 1. So let's define these variables here. The first one I want to talk about is a sub n, and that is going to be our value of the nth term. So in this case, if there were like a 4 here, that'd be the value of the fourth term, or what the actual fourth term in the list would be. D, as we've mentioned, is our common difference. We have n, which is our term number, or the placement in the list, where it falls in the list. So if n is 2, that means the second number in the list, or in the sequence. And last but not least, we have just a, or a sub 1, and that's our initial or first term in our sequence. So a sub 1 is our initial or first term in the sequence. Okay, so let's go over how we can actually use these explicit formulas. So I'm going to turn the page to do that. If you're listening to this while I'm writing this example, if you could send me a quick email and let me know you're listening, that would be great. So again, send me an email if you're listening while I write this example. So I'm going to ask us, what is the 100th term of the arithmetic sequence that begins with 6, then 11, and continues on. Okay, so let's write out our steps here. First thing I want to do is identify the variable values that I know from my explicit formula. So identify variable values for the explicit formula. So here, one other little thing I should note actually is we can find our common difference, which you might intuitively be able to see it's 4, because from 6 to 11 you add 4. But if you want an actual methodology to do this, you can note your common difference, D, is equal to a term minus the previous term. So if you want an actual method you can follow, foolproof, you can do that. So it'd be 11 minus 6 is 4, so that would be our common difference. So I'm going to rewrite our explicit formula just so we can have it here to reference. So that's our explicit formula. I know that my first term, A1, is equal to 6. As we said, our common difference is 4, or 11 minus 6, which is 4. 5, my goodness, it's 5. Why can't I do basic math? I'm sorry, everyone. My common difference is 5. 11 minus 6 is not 4, it is 5. Sorry for that silly math, but my common difference is 5. Since I'm looking for the 100th term, I know n is going to be equal to 100. And I'm solving for my value of the 100th term, so I'm solving for a sub 100. So a sub 100 is what we are solving for. So now I can just plug in all these values into my formula and solve it out. So step 2, we're going to substitute into the formula. So I'm going to say a sub 100 is equal to 6 plus 5, or sorry, 100, wow, I'm getting this, 100 minus 1 times 5. So 6 plus 100 minus 1 times 5, because n, d, a1. Now I'm just going to evaluate it. So I get a sub 100 is equal to 6. Instead of doing 99 times 5, because that's kind of a messy number to multiply, I'm just going to distribute my 5 in, because that will be 500 minus 5. When I simplify that, 506 minus 5 is going to be 501. So my answer, the value of the 100th term, or the 100th term in the sequence, would be 501. All right, let's do a quick check on that really fast. So what is the 46th term? Of the arithmetic sequence? that begins 3, 5, 7 and continues on. So 3, 5, 7. Try that out on your own. I'm going to go over it now. So again, we're using the same formula I used up here. So I'm solving for A of 46. So I know A1 from my list is going to be 3, or my initial term is 3. My common difference, 5 minus 3 is 2. 7 minus 5 is 2. That's correct. And my n value is 46, because I'm solving for the 46th term. When I substitute all that information, I get A sub 46 is equal to 3 plus 46 minus 1 times 2. A sub 46 is going to be 3 plus 45 times 2, which is going to be 3 plus 90, or A 46 equals 93. And that is my answer. All right, make sure you write down any questions on that. I'm going to go over one more type of example for today and a quick check. But our example, I'll fit this here. I want us to figure out what are the second and third terms of the arithmetic sequence that goes 100, comma, blank, comma, blank, comma, 82, and continues on. So what are the second and third terms? So for this one, again, we're going to identify our known variables or values for that same explicit formula. So I know in this case, A1 is 100. I know A4, because this is 1, 2, 3, fourth term, is 82. And I don't know the common difference yet, because I can't subtract a term minus the previous term. So we're going to solve out for what the common difference is by using our formula. So now I'm going to use this and solve for the fourth term in order to solve out for D. So I'm going to say if I had this is my original formula again. So I'm going to plug in 82 for my value, 100 for my first term, plus 4 for my placement. And now I can solve for my common difference to find the last two terms. So step 2, I substituted. I plugged in my values. Now I'm going to solve for D. So I subtract 100 from both sides, and I get negative 18. So I subtract 100. 4 minus 1 is 3D. So negative 18 equals 3D. Negative 6 is equal to D. So then now I just use that common difference. Lastly, use the common difference to determine A2 and A3. So A2, if I do 100 minus 6, I'm going to have 94. If I do 94 minus 6 for A sub 3, I get 88. So those are my second and third values. So again, just did 100 minus 6, 94, 94 minus 6 is 88. And those are my two missing terms from that list. All right, I'm going to flip the page for a quick check, and that will be all we need to do for today. Last thing, same question. I want you to figure out the missing terms if I have 80 blank blank 125. So I'm not going to write out the whole question, but you're solving for the two missing values. Try it out. I'm going to go over it. So again, my first or initial value is 80. My fourth value is 125. So I plug in my value equals my initial value plus 4 minus 1 times D. If I subtract 80 from both sides, I get 45 equals 3D. So D is equal to 15. If I do 80 plus 15 to get my second term, I get 95. And if I do 95 plus 15 to get my third term, I have 110. So I went through that quickly. Make sure you write down any questions, comments, concerns you have on this so we can go over it together in